In this clipping, we will learn the basics of the topic transportation. Now, we have got 4 customers C1, C2, C3, C4. So, let's put them as the customers, and we have got 3 factories F1, F2, F3. The first assumption is that the 3 factories are located at 3 different locations and the 4 customers are scattered across 4 different locations. So let's name them. Assume customer C1 is based at Mumbai. Assume customer C2 is based at Delhi. Assume customer C3 is based at Bangalore, and assume customer C4 is based at Hyderabad. Similarly, we have got 3 factories where the same product is being produced, and all these 3 factories are at 3 different locations. So let's assume F1 is based at Nasik, F2 is based at, let's say, Nagpur, and we have got another factory F3, let's say this is based at Hubli. The basic idea is the 3 different factories at 3 different locations, customers scattered across different locations. In this example, we assume only 3 factories and 4 customers. There can be many number of customers, there can be many number of factories. But this one is an hypothetical example to learn the concept. Now what are these figures 19, 30, 50, 10 each? All these represent cost. How do you read them? Let's say all these are cost of transportation. So let's say cost per unit. What cost? These are transportation cost per unit, which means we read it like this. Cost of transporting 1 unit of the product from factory F1 to customer C4 is 10 rupees. Cost of transporting 1 unit of the product from factory F2 to C1 is 70 rupees. So similarly, cost of transporting 1 unit of the product from factory F3 to C2 is 8 rupees. So all these are per unit transportation cost. Depending upon the number of units that we will be transporting, we will multiply the per unit cost to find the total cost at the end of the numerical. So this is 19, 30, 50, 10, 60, 40, 30, 70, 48, 70, 20. All these represents per unit cost. Now, every factory F1, F2, F3 here has got some restriction, has got some limitations when it comes to production capacity. So here factory 1 has got a capacity of 7. So I can say supply or capacity. These could be in lakhs, these could be in thousand. Let's assume in lakhs. Assume that factory 1 has got a supply capacity of 7 lakhs or 7. Factory 2 has got a capacity of 9 and factory 3 has got capacity of 18. Mind well, all the 3 factories are producing the same product. So if I sum up, this is 18 plus 9, 27 plus 7, 34 is the total supply, which means the company, considering all the 3 factories put together, is able to supply 34 units of the same product. Now let's look at the customers. Customers C1, C2, C3 and C4 are demanding 5 units, 8 units, 7 units and 14 units respectively. If it is in lakhs, 5 lakhs, 8 lakhs. If it is in thousands, 5,000, 8,000. So now customer 1, C1 from Mumbai needs 5, C2 needs 8, C3 needs 7 and C4 needs 14 units. Now let's sum up the demand. 8 plus 5 is 13 plus 7 20, 20 plus 14 is again 34. So what you look at it in this particular numerical is that the total demand from all customers is 34 and the total supply from all the 3 factories is also 34, which means you see that the demand is equal to supply, which means we call such a numerical as a balanced problem. Note that to solve any transportation problem, the problem has to be a balanced one. So if at all you find a numerical wherein the demand and supply are not equal, then you will have to take a step to ensure that both are equal. Either you make a dummy row or a dummy column. I mean, either you assume a dummy customer or you assume a dummy factory. We will look at those illustrations a bit later. However, at this stage, remember that to solve the problem, what is needed is that the demand should be equal to supply. That is what we have taken in this particular base example. So now you know factories have got supply capacity, customers have got demand. To solve a numerical, you need demand is equal to supply. Mind well, when we learn the topic of assignment, even in assignment, there was a topic of balanced problem and unbalanced problem. If you look at the previous topic of assignment, you will definitely recollect that how do you know whether a problem is balanced one or an unbalanced one? In assignment, we look at the number of rows and number of columns. If the number of rows and number of columns are same, then we term that the problem is a balanced one. If the number of rows and columns are not the same, then in that case we term the problem to be unbalanced one. However, in transportation that is not the case. Here we've got 4 columns, C1, C2, C3, C4. Let's not count the supply and the demand. So we've got 4 columns, C1, C2, C3, C4, and we've got just 3 rows, F1, F2, F3, excluding the demand one. So 3 rows and 4 columns does not mean the problem is unbalanced. Therefore, in transportation, to know whether a problem is balanced or not, we do not look at the number of rows and columns. Rather, we add the demand, we add the supply. If demand and supply are same, then the problem is a balanced one. Now that this problem is a balanced one, before you proceed ahead, let's learn that in this particular problem, we assume the matrix to be cost. All these figures 19, 30, 50, 10, etc. represent per unit transportation cost. Now, how do you read this particular sum? Or what is the objective of this particular topic called transportation? The objective is very clear. As a customer C1, this customer needs 5 units of the product. The customer is really not bothered whether this particular 5 units are going to be delivered from F1 or it is going to be delivered from F2 or it is going to be delivered from F3. The product could be manufactured in any of the factory F1, F2 or F3, or it could be a combination as well. The company may give 3 units from factory 1, 2 from factory 2, so 3 plus 2 makes it 5. It may give the entire 5 from factory 3. So, if customer 4 wants 14 units, it may give entire 14 from factory 3. 3 has got a capacity of 18, उसमें से 14 यहाँ पे दे देगा. Or it may give 7 from F1, 7 from F3. Basically, what we mean by this particular example is that as a customer, we are yet not bothered from where the company is going to deliver the goods. We are ultimately bothered about, are we going to get the number of units that we have demanded? But when you look at the same picture from the company's end, the point is not the same. For a company, what matters is that I need to ensure that the demand of all my customers is satisfied in such a way that my total transportation cost remains minimum. Therefore, the objective of this particular topic here is that how do I allocate, or how many units should I allocate from each factory to each customer so that the total customer demand is met and at the same time the cost to the company is as minimum as possible. Therefore, in this particular topic, when you are given a cost matrix, it is very clear we are referring to the concept called as minimization problem. However, if you assume the same figures, let's say these are not cost, but for some time, let's assume these are profit per unit. Which means the company is selling the same product from different factories to different customers. Same product is giving you a profit of 40 rupees when you transport from F3 to C1. But it is giving a profit of 70 rupees when you transport from F3 to C3. It is giving a profit of only 10 rupees per unit when you transport from F1 to C4. Which means the company's product has got the capacity to earn, let's say the maximum profit here is 70. The same product is able to give you 70 rupees profit. But when I transport in F3, C4, I get a profit of only 20. Which means compared to the maximum profit 70 minus 20, what I lose is 50 rupees. So what is this 50? It is opportunity lost, it is regret. Which means whenever you get a problem with profit, the objective here is how should I allocate the units? How should I allocate the available number of units from each factory to each customer so that the total customer order is satisfied, at the same time the profit for the company is maximized. Therefore, whenever it is a profit problem, this is termed as a maximization problem. And in the topic of assignment, we did learn a concept called as a regret matrix or an opportunity lost matrix. The same concept holds true here. Whenever it is a maximization problem, the first step that you will have to undertake is convert the maximization into a minimization and then follow whichever procedure you want to in the initial basic feasible solution methods available. But first is converting from maximization to minimization. That is, you convert the profit into a regret matrix or into a opportunity lost matrix, which we will see in subsequent problems. Here we will learn a few more concepts before we solve this particular problem. Note that every problem, every question in transportation, we will have two levels of solution. The first level of solution is something called as IBFS. It is called as initial basic feasible solution. And the second level of a solution is something called as testing for optimality. So alright, it is optimality testing. And if you find that the solution is not optimal, you need to work ahead using a method called as modified distribution method to make the solution optimal. First, let us learn what is this IBFS, what is this optimality. Alright, initial basic feasible solution. The concept is clear. See, there can be many ways to transport goods from different factories to different customers. There can be n number of permutation combination available in this particular problem. So for example, I can transport 5 units that this particular customer requires from factory 1. It has got 7 units. I can give 5 from factory 2. It has got 9 units production capacity. I can give 5 from F3 as well. It has got 8 units. I can give 3 from here, 2 from here. So there are multiple ways, there are n number of ways possible to transport the total 34 units to all my customers C1, C2, C3, C4. All these solutions which are possible in this particular problem, we will name them as feasible solution. Typical in statistics in operations research, what is a feasible solution? What do you mean by feasibility? Feasibility generally means any solution which satisfies all the given constraint in a particular numerical is called as feasibility. So far as you are able to satisfy all the constraint, it is a feasible solution. So far as I am able to transport all the requirements, 34 units, to all my customers as per their demand, it is a feasible solution. However, now note that there can be only one solution possible which will give you least possible cost, and that solution and that method of transportation, that allocation which will give you least possible cost of transporting your goods, that we will term it as optimal solution or optimality. So the first step is arriving at an initial basic feasible solution. Once you arrive at a solution, you need to check whether is there further scope to reduce cost in the solution that we have made. Yes, if there is further scope to reduce cost in the solution that we have made, it means that this given solution or this obtained solution is no more optimal. I need to work for optimality. But once you make the IBFS, when you get the IBFS, if you are able to prove that this particular solution is the solution with least cost, there is no other way of transportation possible wherein I will be able to reduce my cost. If I can prove that, in that case I will say that this particular solution is optimal. Which means when I talk about a minimization problem, I need to prove that the way that I am transporting this is the least possible cost, or cost kam hone ka possibility nahi hai. Then I can say it is an optimal solution. And when it is a maximization problem, I need to prove that the way I am transporting my goods, this is going to give me the maximum possible profit. इससे ज़्यादा profit कमाने का possibility नहीं है. So if I can prove this, then my maximization problem becomes optimal. Therefore, any problem, the first step is check whether demand and supply are same. If it is same, it is a balanced problem, we can continue. If it is not same, we will look at what is to be done. Then you decide whether it is a minimization problem or a maximization problem. If it is maximization, go for a regret matrix. Else, if it is minimization, directly start with the problem to find initial basic feasible solution. Once you find initial basic feasible solution, you check for optimality. If the solution is optimal, well and good, the conclusion sum is done. If the solution is not optimal, you use something called as modified distribution method to get the optimal solution. Now the question is, how do you find IBFS, initial basic feasible solution? Note that to find IBFS, we have few methods. One is called as northwest corner rule, NWCR, northwest corner rule. One is called as least cost method, LCM, and one is called as Vogel's approximation method, VAM, Vogel's approximation method. We have yet few more methods, let's say row minimum, let's say column minimum, row minimum, column minimum. Mainly we use northwest corner rule, least cost method and the Vogel's approximation method. If nothing is mentioned in a given problem, we generally use Vogel's approximation method. Note that when you solve a given problem for initial basic feasible solution using each of these methods, you will get different answers. Does not mean that all the answers are right or wrong. There are different ways of transporting goods from each factory to each customer. That's what we said, that all these becomes initial basic feasible solution. It does not mean that all these solutions are optimal. No. Once you find the IBFS, the further step is to check whether solution is optimal or not. And if at all the solution is not optimal, we work for optimality. Now this is what is introduction to a topic called as transportation. We haven't solved the numerical yet. As of now, we have only learned how to read a given matrix. What do you mean by supply? What do you mean by demand? What do you mean by a balanced problem? What do you mean by unbalanced problem? How to identify whether it is a minimization or a maximization? And how to proceed, what are the steps in solving a typical transportation problem. Now, in the next video, we take up the same numerical and we will solve it with each of these methods, northwest corner rule, LCM and VAM, to find IBFS, initial basic feasible solution. Further, once we are through with initial basic feasible solution, we will learn for optimality. But this one should help you to learn the concept of transportation. Once you are thorough with the basic concepts, we can definitely go to the topic of IBFS, NWCR, LCM, VAM. Thank you.